When joining thick section aluminium to thin section or a small part to a larger casting, always apply the greater amount of heat to the larger component and use the heat transfer from the larger mass to remelt the Technoweld in the join area. In this example, a thin coat of Technoweld has been applied to the aluminium can, and the edge of the piece of aluminium has been coated. Remember, the thickness of the side of the can is about as thin as you can get aluminium, and the mass of the piece of aluminium is greater than the whole can. The heat is applied to the aluminium piece only, until the heat transfer melts the Technoweld on the side of the can. It is not always possible to know whether a type of cast alloy will melt below the melting point of Technoweld just by looking at it. If the metal melts at about the same temperature as Technoweld, or even slightly before, then you apply Technoweld using a different technique. To test the melting point of a suspect metal, place a small piece of Technoweld and a similar sized sample of the metal on a flat metal surface, and heat evenly from below, checking to see when the sample melts. In this case, it is melting at just about the same temperature as the Technoweld. To apply Technoweld to a low melt metal, the process is closer to a conventional welding approach. Warm the workpiece generally. Then, using a smaller, more concentrated flame, heat the work area, continually prodding it with the stainless steel abrader until you see the surface just starting to lift. Then you heat the Technoweld rod into the job as you would do for a conventional weld. There are really only two problems you might encounter. A joint cracks or is very weak. This is caused by the joint cooling too quickly because heat has been too localized in the joint area. There should be sufficient heat in the aluminium to keep the Technoweld molten for at least 6 seconds. On large section aluminium castings, cylinder heads, etc., the Technoweld should stay molten for 15 to 20 seconds. If this problem occurs, reheat the job, but not directing the flame onto the Technoweld. Heat the general surrounding area only, until the Technoweld remelts, and let the job cool slowly. This slow cooling allows the Technoweld to form a large, strong crystalline structure. Fast cooling results in a small granular structure which is inherently weak. The rod does not seem to take. This is caused by the Technoweld rod being heated by the flame, either because it is being directly heated or because the flame is not being moved far enough away when using the rod to check the temperature of the aluminium. Keep the rod well away from the flame. It is essential that the heat from the workpiece melts the rod. This is the only way you can ensure that the Technoweld and the aluminium are at 380 degrees centigrade at the same time. Molecules of aluminium start to leave the surface at 380 degrees centigrade, and the Technoweld grabs these molecules to start the process. If the Technoweld is at 380 degrees centigrade before the aluminium, it has nothing to grab.